All right, welcome back. So the last video we looked at the unit circle definitions and how to evaluate trig functions off of that. But again, that's not the only way. So another way is to use triangles in SohCahToa, and a lot of students like this way because it brings them back to geometry and they're kind of using what they've already seen before. So it's not necessarily on the unit circle, it's just any circle that's been centered right at the origin. So you still have a radius, and it's still intersecting the circle at a point, x, y, but we're going to draw a triangle out of this. So when we do this, you draw a line from the point to the origin, and then you're going to draw a line from the point and you're going to connect it to the x-axis. So if your point was down here, you draw it up. So you're either drawing the line up or down, so it's always vertical. And then draw in the other leg of the triangle along the x-axis. And that's how we're going to draw them for the entire class. That's how you usually draw it in calculus too. When you get into physics, sometimes they're going to try to connect it to the y-axis, which is fine. You just have to be aware that your definitions are going to flip around a little bit. But in this class, this is how it's going to be done. Okay, so you have a radius in R. The purple side is y, and then the green side is going to be x, because you got to go over x and up y to get to the point. And we still have the angle theta right in there. So the r, that is the hypotenuse. The y, that side is considered the opposite because it's directly opposite of theta. And then the x side is the adjacent because it's right next to theta and it's not the hypotenuse. So the definitions for the trig functions are going to go off of the sides, the opposite, the adjacent, and the hypotenuse. Excuse me. And so that's where SohCahToa comes into play, because SohCahToa tells you like which side goes with which function. So sine of theta, if you follow how it's spelled, it's going to be opposite over the hypotenuse. Cosine of theta is going to be the adjacent over the hypotenuse. And tangent of theta is going to be the opposite over the adjacent. So then the other three trig functions have the same idea as they did for the unit circle definitions. They're just pretty much the reciprocals. So the hypotenuse over the opposite. For cosecant, secant, hypotenuse over the adjacent. And for cotangent, the adjacent over the opposite. So if you're going to be using this method with SohCahToa, you need to know two special right triangles. The first one being the 45, 45, 90, and then the second one is the 30, 60, 90. Because these two triangles are going to go with any angle that's on that circle. That's a multiple of 45 or a multiple of 30, and then depending on how it's oriented, it'll tell you like what the sides are. So the 45, 45, these two sides are always 1. Oops. Because it's basically an isosceles right triangle. So if these two angles match, then the two sides are going to match, and they're always going to be a 1. If you use Pythagorean theorem, that gives you that side of the square root of 2. Now for the 30, 60, 90, if the 60 is up here and the 30 is over there, the sides go 1, √3, and 2. So the 1 is always directly across from the 30, the √3 is directly across from the 60, and then the 2 is the hypotenuse. So no matter which way you go, you are going to have to memorize something. So some people just want to memorize the triangles, other people want to memorize all the points. So it just depends on what you want to do. But let's see how to use SohCahToa to evaluate your trig functions. So sine of 60. So what I usually do is I just draw the triangle out so you can see it. So 60 is going to be here. So whatever this angle is, that's the angle that's in the triangle that's hitting the origin. So if this is 60, that's going to be 30. So you have a 30, 60, 90 triangle. So you just have to label up your sides. So the 1 is across from the 30, √3 is across from the 60, and 2 is the hypotenuse. So sine is opposite over hypotenuse. So opposite over hypotenuse. And there you go. Cosine of 135. 135 is in quadrant 2. So for angles that are over 90 degrees, you're going to use what's called a reference angle. So you can figure out what angle is actually inside the triangle. So in this case, excuse me, that would be 45 degrees. So you now have a 45, 45, 90 triangle. So 1, 1, √2. So cosine is the adjacent over the hypotenuse. So 1 over √2, and then if you rationalized it, √2 over 2. Okay, tangent of 7 pi over 4, that's in quadrant 4. And sometimes it's easier if you flip it around into degrees. So 7 pi over 4 is 315. So that's what rotates all the way over there. But we want the angle that's sitting inside of the triangle, which in this case is another 45 degrees. Okay, and then just remember, you're always drawing the leg either up to the x-axis or down to it. Don't draw it and connect it to the y. If you do, your functions are all going to flip around, and they'll be out of order. So tangent, opposite over adjacent, so 1 over 1, or just 1. Whoops, and I totally forgot something. I can't believe I did this. You also have to be kind of cognizant of where you are. So like on example B, this side over here on the x's, that's in the negative x's. So that's really like a -1. The -1 is not really representative of a length. It's just the negative is representative of the sign that's going to be associated with that side. So in our case, that's going to make the answer negative. Now for tangent over here for this one, this side over here, that's on the negative y's. So that side gets a negative. So that's going to be a -1. All right, let's finish this one off and then we'll stop the video. So cosecant of 2 pi over 3. So 2 pi over 3, that's 120. So we're back in quadrant 2. So 120 is the outside angle, which makes this angle 60. There's 30, so 1, √3, and 2. And the one down here is going to be a negative because you're on the negative x's. The y is still positive because it's on the positive side. So cosecant hypotenuse over the opposite. So 2 over the root 3 over 2 root 3 all over 3. Okay, so that's how SohCahToa goes. It does seem longer than just using the unit circle, which is true, but you have to know how to construct the unit circle first before you even start these. So, I mean, there's pros and cons to each of them. With this, they do get faster. Like, eventually you'll probably be able to draw these things in your head and not really have to do anything. But again, it's going to be up to you to find what method works best for you so that you can answer these questions. All right, stop here and we'll continue on in the next video.